CO2, reality or hype? That was really what I wanted to speak about. I'll get my two pennyworth. Many years ago, I was a marine climatologist. There wasn't a career in the late 1960s in marine climatology, but I've kept a very close interest on that area, and the amount of information available is fantastic. What's the first bit of information? Well, first of all, some research. More and better scientific data on climate change will only convince the convinced. A new study shows that people will question the research behind climate change if the results clash with their beliefs. And this was produced by the National Environment Research Council. And I have to say that particular statement tallies with all sorts of things, and I think not just climate change. We tend to dismiss evidence if it doesn't actually agree with our beliefs in all sorts of areas. But I'm going to at least try and convince the convinced even more. And I've been doing some work recently with a company called Danwood, who's a big reprographics company, and I asked the question to them, how much CO2 does the public sector use or release for reprographics? What's the carbon footprint for public sector reprographics? And Danwood did quite a lot of work, and they came with a figure of about 300,000 tonnes a year. That's just public sector reprographics. And then I did a bit of work, and it equates to doubling the CO2 over the Wembley football pitch, which is 110 by 96 metres, I think, to a height of 28,750 kilometres. That's assuming standard air pressure, sea level air pressure up to that height, which of course is nonsense. Last night I thought, well, I wonder how that compares if we actually think of it in terms of the United Kingdom area, what happens there. And I calculated that it's actually equivalent to doubling the CO2 over the United Kingdom to a height of 1.16 metres. And that's just our reprographics footprint and just the public sector. And reprographics is a pretty small proportion of the public sector carbon footprint. And if anyone can tell me what the total carbon footprint of the public sector is today, I'll do a similar calculation for the whole of the public sector footprint. And I'll try and get some sort of estimate for you for this afternoon. So it just starts to picture. Now, why is carbon dioxide important? Why is it a greenhouse gas? It's very simple, actually. All gases on the Earth absorb heat from the sun, radiation from the sun, and they radiate it back. But CO2 radiates it back more slowly than most of the other gas in the atmosphere. And therefore, the more CO2 there is, in other words, it retains its heat longer, so the more CO2 there is in the atmosphere, the longer the heat is retained. And if the atmosphere isn't able to cope by absorbing all that extra CO2, then the amount of carbon dioxide increases gradually over a period, a bit like bank interest. You don't need much of a surplus each year for it, after, say, 25 years to be quite a big increase. What impact is that having then? Well, this, I thought, and you'll just sort of have to try and picture this. This is a view of the Arctic ice 3 days ago. And it's thinking back to the late 1960s, it is breaking up extraordinarily quickly. It is disappearing very quickly this year. And obviously with that projection, the land masses look bigger than they really are. And why is this important? Well, because sea ice reflects about 80% of solar insolation from the sun, and sea water absorbs about 80%. So if the sea ice starts to disappear, you get a feedback mechanism, but unfortunately it works in favour of heating the Earth up more quickly than it would otherwise do. And this gives you an idea of how this year's sea ice compares with previous. The dotted line at the top, I'll have to explain these, is the average for 1973 to 2008. So this, again, was 3 days ago. The red line is this year's Arctic ice. And it did expand to a bigger area than recent years, but it's dropping very fast now because it's actually extremely thin this year, very thin indeed. And all the other lines are the from 2004 onwards. So you can see there's been a huge drop since the year 2000 in the area of Arctic ice, and this year it's dropping faster. And I did check the figure yesterday, and that red line would actually be significantly further away from all of the others. If this was today, it's bombing at the moment, the Arctic ice. So that's obviously going to have an impact on climate. And we had a cold winter, and I thought, well, OK, let's see what's happened to April. And these are temperature anomalies. In other words, is the atmosphere warmer or colder than average? And this April was the warmest April on record, and the reds mean that are areas where April was warmer than average, and the blues are where April was cooler than average. And the big red blobs are where it was 5 degrees or more warmer than average. And I have to say, and this year so far has been the warmest on record. The last 6 months have been the warmest on record. Whilst we had a cold winter, parts of Canada, all of Canada had temperatures above normal. Parts of it were 15 degrees above normal. If we were 15 degrees above normal in January in London, it would be the equivalent of a hot summer. So whilst, if you like, we tend to think about what's happened here, globally there are massive changes taking place. And this is the warmest on record, and I think May is almost certainly going to be ahead of time as well. You can get all this information, by the way, on something called Weather Underground. If you want, just type in Weather Underground and you'll get masses of information with a blog that keeps it up to date. So that's the bad news. We'll probably hear some good news and bad news today.